So, yesterday, we only did one problem that was a composition, and you found the domain, right? Okay, so I want to work two more today, and then I want to look at a greatest integer function, and then we'll be through. Okay? So we're going to look at another composition and talk about its domain. Now, when I talk about a domain of a composition, what did you have to remember? On who?
Oh, is that composition?
Domain
Oh, you mean
of a composition.
it was the second function in the composite.
Very good. Domain of a composition. When you look at the domain of a composition, you only have to take into account, you only have to consider the domain of the second function and the composite.
Is the composite the one that's made after?
It's the one that you get, your answer, okay? The domain of the second function and the composite. All right? So we did one yesterday, all right? And I want to do two more today. Okay? So here's the first one. I'm going to tell you that f of x is equal to x squared minus 9, and g of x is equal to the square root of 9 minus x squared. Okay? All right, so I want you to find F composite G. All right, I'll give you about a minute and a half. You find F composite G. What? You were out golfing.
Actually, he was sick, so he wasn't. We all thought it was a golfing, so we didn't know why it wasn't.
Very good.
Did you just get rid of square root?
Mm-hmm.
And negative x squared, is that right? You want to do like an interval?
Yeah. No, you can just hang on to it. All right, everybody got this? F composite G? Okay, before we start on this, I just want to address something. I want you to make sure that you have algebra skills, okay? That whoever your teacher was last year taught you some algebra skills, and you remember them, okay? So I'm pretty sure she taught you some skills. Now, whether you remember them or not, y'all look. The square root of 9 minus x squared. Can't we just go, the square root of 9 is 3, and the square root of x squared is x? Yes or no? Why? Very good. Because they are subtracted. Now, if it was 9 times x squared, could you do it? Yes. But y'all, if it's added or subtracted, you can't do that, all right? So make sure you don't do crazy stuff like that. All right. So now we're going to do this composite function. F composite G just means f of g of x. So I put the g of x function, what it was equal to, right here. Now we go to the f function, and everywhere there's an x, I'm going to put this in there for it. Okay? So there's an x, so I'm going to put 9 minus x squared, and then I got to square this x. So I'll square it, and then minus 9. Really, guys, all we did was we plugged the g function into the f function. Okay? That's all you're doing. Now, what does this square do to a square root? Yeah, they just cancel each other. They're opposites. Powers and roots are opposites. So then you're left with 9 minus x squared minus 9, which is what? Negative x squared. So this is F composite G. Okay? Everybody okay with that? All right. So that's one of the answers that I asked you to find. Now, I want you to tell me what the domain of F composite G is. Now, when I talk about its domain, who do I have to take into consideration? Okay, the second function, so that's this one right here, and the composite function, which is this one right here. Okay, I have to take these two things into consideration. So, this one right here, guys, did we just have a test on this?
Yeah.
We did, okay? So if you didn't learn it for that test, you better learn it for this test. It's going to get you again. All right, so it has a restriction. It has an x squared under the radical. So you take what's under the radical, and you say you must be greater than or equal to 0. And then it gives you a quadratic inequality, which is not as easy to solve if it's just, 3x minus 4 greater than or equal to 0, a linear one. All right, so remember how we did it. We did it by graphing it, and all we need to know are the x-intercepts, or the answers if this is set equal to 0, okay? So, I'm going to do it like this. This wigged a whole bunch of kids out this morning because I said find the x-intercepts, and so I just took that and set it equal to 0, and they all went crazy. Like, oh, you can't change that just to an equal sign. It says, how do you do that? Like, what's the only thing I'm trying to do?
Find zero.
Yeah, find the zeros, people. Guess how you find them? You set it equal to 0, and you solve for x. Okay? I'm not changing the problem. This is the problem that I'm trying to find. Okay? So, I'm going to add x squared to both sides. Now what am I going to do? Square root it. Now, you were taught whenever you're solving an equation and you take a square root, you have to put plus or minus, and the square root of 9 is 3. So there are my zeros, -3 and +3. Everybody with me? Could you also have factored it? Yeah, that's the difference in two perfect squares, people. Factors into x, 3 plus x and 3 minus x. Okay? This one will give you a -3, and this one will give you a +3. So either way you want to do it, it doesn't matter to me. All right, so there it is. What's the next thing you have to look at? Yeah, how your parabola opens, up or down. How does it open? Y'all, that's very important, okay? Because if you don't have your parabola open up, if you just make it always open up because you're not paying attention, you're going to miss some of those answers, okay? So there's my parabola. Now, I want the part of the parabola that's greater than 0. Would that be above the line or below the line? So that would be the hump. Everybody agree with that? Where are the x's on this x-axis that give me the hump? Between or outside? Okay, so they're between. Now, do they include the -3 and +3 or exclude them? Because it's greater than or equal to, so it has to be inclusive. So what is the domain of this function, guys? -3 to 3. That's his domain, okay? We had to do all that work just to find his domain. Now, what about this function? What's his domain? Yeah, -infinity to +infinity. Now, here's what you have to do. Any restrictions in either one of these places have to be applied to the domain of the composite function. Okay? Guys, listen to me. I'm using this function to make this function. So wherever this function does not exist, this function won't exist either. Okay? So what's the domain? That's it. Okay? That's it. Now, is there a way that I could check this on my calculator? Okay, so here's my question. Can I just stick this in my calculator?
No.
If I put that in y equals, what's it going to show me my domain is? -infinity to +infinity, because that is his domain. This is what you have to put in your calculator to make it take into consideration this function up here. It has to see, oh, you built that function from this function, so that's going to include those restrictions. Okay, so I'll show you how to do it. I'm going to take my calculator. Oh yeah, y'all crashed my computer, so it was closed out. That's okay, it's working though.
What it needs.
That's right. Sometimes it crashes, just what you need. Alright. So, we have to put it in there. I'm going to put it in parentheses. Don't really know if you have to, but I like to be a little safe. So, the square root of, what was it? 9 minus x squared? Okay? And then, mine has to have 2 sets of parentheses. Y'all's, the radical keeps going on out, forever. Mine doesn't do it that way. It makes parentheses. So, now I'm going to square that. And then, what was it, minus 9? Yes? Okay, so now I'm going to graph it. Now, when I graph that, my picture's not, it's not awesome, right? Because I look at it and what do I think? Yeah, I look at it and I go, oh, it looks like a parabola to me. Okay, so I'm not really sure. So where else should I do? Yeah, go to your table. I'm going to go to my table. I could check some values, couldn't you? You could go a second and calculate some values. But I'm going to go to my table and show you what my table's going to tell me. Oh, look at there. Look at there. What's my table saying? Everything after what? Yeah, everything after 3, it's not working, people. So, that's looking pretty good for me. I'm going to go check the other end. Oh, there it is again. And everything before negative 3, they don't work. So, is my domain good? Yes or no? Yeah, very good. All right, let's do another one. Now, don't you hate it when the teacher teaches you something and then you're like going, oh, that's crazy. When are we ever going to use that? Okay, so I didn't want you to learn how to work complex fractions and not ever have to use them. So, Merry Christmas. Oh, it's an early Christmas present, okay? I want you to find F composite G, and after you find it, I want you to tell me what its domain is, okay? You have 2 minutes. Go. F composite G and find the domain.
What the heck? I don't know. If it's 1 over the top, it's not
But not until you get it 1 fraction.
We mean so I can't have a plus 3?
You have to collect like terms. Can't do any of that flipping and stuff until you make 1 fraction on the top and 1 fraction on the bottom. 1 fraction on the top shouldn't be hard for y'all. Y'all should be okay with the top. If you can't do the top, we got bigger problems, people. You see me after class. I need to find you a new schedule.
Can I do it like that?
Oh, something's wrong with it. You made a mistake.
Do I take a 3?
No.
I guess I'll have to put over 1 right on that.
No. Multiple choice, I don't have to write out. That's right. At least take a good bit. At least take a good bit.
Oh, plus 1. I was close. So it ends up being 11. Yeah, I'm struggling. Look, Trey, not everybody's born a natural math person, okay? We have to work.
I don't know if I'm doing this right.
Yeah, that's what I thought. You're struggling now.
Well, I think I did it right. It's just kind of messing me up a little bit.
Yeah. No, these are those ones, remember, Becky, I bought Becky some like this for Christmas, and then I wore them before I gave it to her, because they matched my shirt so well. And then I told her I messed up, and she found me some like them, and she got them for me.
I'm on the right track. These all judge me so much. You know, they're doing me. These are all born natural math people. I have to work it.
All right, y'all got it? Okay, so here's what I did. I just plugged 1 over x minus 4 in for this x. That's where it came here. In order to collect these two right here, what do you have to have? A common denominator. What's the common denominator between x minus 4 and 1? Okay, this is already over an x minus 4. If it ain't broke, people, don't be fixing it. So that's just a 1. This one, you have to multiply by x minus 4, so I multiply the top. I don't have to write the bottom one down, guys. You could if you want to, but it makes your problem get really messy when you do that, all right? So that's why I choose not to, but you can. Now, be careful right here, because I saw a lot of mistakes. It's what? Plus 3x what? Minus 12. I've seen people write 4 right there quite a bit today, okay? Any like terms? Yeah? So this is 3x. What's a 1 and a minus 12? All right. Now, here you can invert and multiply, or you can just think about this. Y'all, when you put 1 over something, what does it do to it? Takes its reciprocal. That's all it does. So all I'm doing is taking this fraction's reciprocal, or you could use that old rule, invert and multiply. Okay? But either way, you get x minus 4 over 3x minus 11. So that is my composite function. F composite G is x minus 4 over 3x minus 11. Now, let's talk about his domain. If I'm going to talk about his domain, I have to talk about G's domain and his domain. All right? Here's G up here. Does he have any restrictions? What is his only restriction? X cannot be equal to 4, right? An x in the denominator, you set it equal to 0. You solve for x, and then you say x cannot be that. So that's his only restriction. Does this one have any restrictions? What is it? X cannot be 11/3. Okay? So you set this equal to 0 and solve for x, it'll give you 11/3. You exclude that number. Okay, so what's the domain of the function in interval notation? Negative infinity to 11/3, because 11/3 is smaller than 4. Okay? Union 11/3 to 4. Union 4 to positive infinity. What if we did it in set notation? What would it look like? Very good. X is an element of R, all real numbers, except X cannot be 11/3, comma 4. All right? Very good. Very good. Okay. So everybody okay with this? All right. So here's the last thing that we want to talk about. Greatest. All right. Now, y'all listen. Last year, when you did this, you hated it. Okay? Kids normally don't like this function because they don't see it very much. All right, but I want us to learn how to work with this function, okay? The greatest integer function. Sometimes this is called a step function. When we graph it, you'll understand why they call it a step function. It does look like steps, okay? But we're going to graph the parent function, and then from the parent function, I want you to be able to find all these other things that I'm going to give you, okay? Just by using your rules of transformation. Okay, so here's what it looks like. F of x is equal to. This is a greatest integer function. It's a double barred bracket. Okay? It's just a bracket, and it has double bars. Now, first of all, before we start talking about it, now look, if you don't know what something looks like, you can always graph it from a T-chart, right? I will say, it does help to know a little bit about it, because you might, you're going to have to, it helps to pick specific points, okay? So I'm going to help you pick the points. Now, I'm going to pick -1, -0.75, -0.5, -0.25, 0, 0.25, 0.5, 0.75, and 1. Okay? I know it seems like a lot, but it's kind of a weird looking function, so it might take us a little bit before we see a pattern. Okay, so first of all, you need to know what an integer is. What's an integer? It's a whole number or it's opposite. Okay? Whole numbers, remember, those are the numbers that start with O, whole. And so that's 0, 1, 2, 3, 4, 5. And they're opposites, -1, -2, -3. So when I say integer, your brain really thinks no decimals and no fractions. Okay? That's what my brain says. Hey, integers, no fractions, no decimals. All right, so this is the greatest integer function. So sometimes, I'm just going to show you on a number line, because sometimes kids get really mixed up on this. -1, 0, and 1. Those are the only integers I have up here for my x's. Okay? So here's what I'm asking you. If I put -1 in there, I want the greatest integer not greater than -1. Yeah, it's -1. Okay? See, here's -1. What's the biggest integer that's not bigger than -1? -1. You see what I'm saying? Okay, here's -0.75. Right here. What's the biggest integer not bigger than -0.75? -0.75 is not an integer. It's -1. It's -1. It can't be 0 because 0 is what? Bigger than it, okay? All right, here's -0.5. What's the biggest integer not bigger than -0.5? -1 again. Okay, let's go over here and look and see what that looks like. At -1, it's -1. At -0.75, it's still -1. At -0.5, it's still -1. What about -0.25? It's still -1. But what is the biggest integer not bigger than 0? 0. Oh, at 0, he jumped up to 0. So here's what the thing. He stays -1 up until you get to what? 0. Yep, an open circle, because 0 is not included in that one, is it? Okay, and then what about 0.25? What's the biggest integer not bigger than 0.25? Not bigger than 0. So 0.25, he stays at 0. What about 0.5? Still 0. What about 0.75? Still 0. What about 1? Oh, so at 1 it jumps up to 1. So he stays 0 until you get to 1. I'll show you tomorrow. Okay? Now, do you see the pattern? What's he going to do? Stay 1 until what? You get to 2, and then he jumps up to 2. And he's going to stay 2 until you get to 3. And then he jumps up to 3. And then he'll stay. And now do you see why they call it a step function? Okay, so here's the real problem. Everybody ready? What if I said, plot this? Plot this. All right, there it is. What if I said plot this one, guys? Could you use what you know about transformations and plot this graph right here?
Right 2 and up 1.
There you go. People, take this one little stair and move him where? Right 2. I'm going to start at the solid point, and I'm going to go right 2 and up 1. So he goes here, and then he goes to here, and then he goes here, and he goes to here, and then he goes here, and he goes to here.
So let's do 3 steps. How many steps we got to do? When we actually do
There you go. That's it. Yes. Because it's open. It says, remember how we did this one? It's -1, -1, -1, -1, until you get to 0. And then it jumps up to 0. So he's -1 all the way up until you get to 0. So it's just an open dot. Okay? All right, what about this one? See if you can do this one. I did. It looks like I didn't. I know. The other class told me I did it wrong. They made me erase them all. And then I was like, y'all are so lying. It just looks like that. But yeah, see how I took this one and I went over 1, 2, and up 1. There he is.
Does this one just go up?
Okay? All right. Now,
We got you now.
You just go over 1, then up.
Let's go up. Yeah.
now look, y'all, it didn't say +2. He's not going up 2. Okay? What's that 2? Yeah, that's exactly right. This is a vertical stretch of 2. So what is it doing to the blue one? Yeah, it's made stairs for what kind of people? Tall people. All right? So my risers now are not 1 apart, but they are 2 apart. So it looks like this.
I don't like it.
Okay? No, I didn't. 1, 1, 2, over. Hang on just a second. Let me draw this last one. Okay, what now? Huh? If it was 1/2, there'd be 1 here, and then there'd be 1 here. It's going to shorten. It's a compression. Okay? I'm not going to show you today, I told ya. Okay, watch this. Let me give you another one. This one's going to be much more difficult because where am I going to put the 2? Oh! In there with the X. Okay. Do they get longer?
They get shorter.
Yeah. He's an X, guys, and they're always weird. Okay? X's are always weird. So when I put a big number in there with the X, instead of it being a horizontal stretch, it's a horizontal compression or shrink. Okay? So what is this 2? Come on. Dadgummit. Okay, so what does that 2 do to the, now look, the blue one is the parent function, okay? So, here he is right here. What happened?
What are you doing, Miss David?
I'm trying.
What are you doing with your life?
Look, it's off. Look how off it is. It's recording.
Hurry, run, Forrest.
All right, so here's what it's going to do. It's going to start here. Instead of going all the way over to go 1, what's he going to do? Yeah, he's just going to go halfway, guys. And then he's going to go up here, and he's going to go here. So then he's going to go here to halfway, and then he's going to go here to halfway. You see what I'm saying? He's got some little bitty shorts. That's right. If I put a 1/2 right here, then he would go from here over to here. He would make long risers. This makes short risers. Okay?
Say nothing.